Okay, now audible? Is it audible now? Is it audible? Previously also the mic was on. It's audible, right? Okay, great. Maybe a restart is always the best option, right? If something do not work. Hello. So basically what I was telling is, like, today is the last lecture of single variable calculus, and in today's class we'll be talking about the applications of definite integrals to a great extent, and also we'll discuss about the some special functions like the beta function and the gamma function as well. Okay, it's slowly audible. No, I think so. The pulses is fine. Yeah. Okay. Yeah, everything is on sync. Fine. So this is the Telegram channel, so that if you just follow this channel, then ultimately you'll be getting notified with each and every session that's happening on this YouTube channel, so that you don't miss the continuity, of course. Okay, and in this, basically this is my group managed by me and my students as well, so it's like for the mutual learning. Okay, and at any point of time, if you feel that some guidance can be sought from me, then you can just post it in this group. Me or my students will be definitely helping out each other. Okay, and in Unity platform, you'll be having the concise of all your doubts and explanations at a single point, so you can install and sign into this PW Unity. And of course, before you ask your doubt, you can type exclamation doubt, and then if you start your doubt, then definitely it gets stored at a particular point. Similarly for the notes as well. So if this can be done, then ultimately it gets saved at a particular point in at a one-stop solution. Like it's like a one-stop solution, because everything that you have that you need clarity will be definitely available at a single spot. Okay, and in the last lecture we were talking about, see, in Friday's class I have given you some homework as well, of course. So in Friday's class we talked about properties of definite integrals, where we have seen some nice properties basically regarding the reduction functions, reduction integrals and all. So properties of definite integrals is what we have seen. And also we have talked about the application, only one application, area between the curves. Okay, so area between the curves, of course. Okay, so area between the curves, we have seen that normally if two curves are, Unity is a app name. Yeah, basically you can just log in and you can type PW Unity, it just shows you. Like, maybe if you want, I can just show you. So PW Unity, so if you just sign in, the first link Unity is what you can just click, then it will direct you to the login page. Okay, so once it directs, of course mine is already logged in. So normally if you don't log in, it will ask you if you sign in with a Google, so just click on that. All you need is just a mail ID. So maybe I'll just type this. So that's it. Okay, so login successful. Then you have all your, of course in my classes I don't participate, obviously you are the guys who participate, otherwise all your things gets reflected in this particular single page. Okay, so that's all. Now these are the two things I have given you in the last lecture. So in today's class we'll be talking about applications, more applications of definite integrals, like calculating length of a curve, okay, or basically calculating surface of a revolution, or basically calculating volume that you get when you evolve a curve about any axis. Okay, and then we'll also talk about gamma and beta functions, basically improper integrals, and we'll see that this gamma function is one first kind of improper integral, and it's also called this the second Euler's integral and first Euler's integral. We'll see this in details. Okay, before going for the topics today, I have given you some homework actually, so I think many of you might have done it. Hello, let's solve this question. Integer type, 30 seconds. If you have already solved this integral, then enter the answer. If integral 0 to 2 pi x sin x dx is equal to k times pi, then the value of k is equal to dash. Come on, enter this answer. I have given you this as a homework, so if you have solved this already, then please enter the answer. 4 is the answer, Pranav? Maybe, I don't know. Let's solve. So integral 0 to 2 pi x into sin x dx. Okay, so let's solve this question. Solution: I is equal to integral 0 to 2 pi x into sin x dx. Now ultimately I have told you one point. If this function which is inside differential is not inside the modulus, is not differentiable at some point between 0 and 2 pi, you have to split the integral. Okay, so clearly this x into sin pi is 0 at x equal to pi. Okay, so at x equal to pi, this modulus function is not differentiable, because ultimately you'll have a sharp edge. Okay, so at x equal to pi, this function will not be differentiable, of course. So we have to split this integration. Integral 0 to pi mod x sin x dx plus integral pi to 2 pi mod x sin x dx again. Okay, so this is what you get. Now tell me one thing, when x is lying in between 0 and pi, what would be x into sin x? Is it positive or negative? Please tell me. When x lies between 0 to pi, ultimately x is positive because x is positive here, 0 to pi. What about sin x? When x is lying in between 0 to pi, it is positive. So within 0 to pi, x is positive, sin x is also positive. So this complete product is going to be positive as well. Okay, so this is positive. But coming to here, this x into sin x is going to be negative. Okay, because from pi to 2 pi, x is positive, but sin x is negative. Obviously, it falls into the third quadrant and I mean third and fourth quadrant, so it is negative. So when the value inside the modulus is positive, the mod function is as usual the same function. Okay, x into sin x dx plus. Now here, when the thing inside the modulus is negative, ultimately mod value is pi to 2 pi minus x sin x dx. Correct? So this minus sign will actually come here. Okay, the reason is you all know that mod function is equal to x if x is positive, or basically 0 of course, and minus x if x is negative. Correct? Because you know the outcome of a mod function is always positive. So if x is negative, then minus x is positive. That's it. Okay, so this I think I have given enough explanation on this when we are talking about 1.0 lectures. Then let's see if you integrate this. Now what about the integration? Let's see. If you integrate it directly, x into sin x. So x into integration of sin x minus cos x minus derivative of x 1 into integration of this minus cos x is plus sin x, of course. Okay, because integration of minus cos x is minus sin x actually, so minus of minus gives you plus, of course. So this is within the limits 0 to pi minus, I am pulling out this minus. Now x into sin x integration is again same thing, minus x cos x plus sin x within the limits pi to 2 pi, of course. Okay, so this is for pi to 2 pi. So let's substitute the values. So if you substitute the values, first of all, when you put pi here, this is minus pi times cos pi is minus 1 plus sin pi is 0. And when you put the lower limit 0, this is 0, this is also 0, so this is totally 0. Minus, so when you put x equal to 2 pi, minus 2 pi, cos 2 pi is 1, sin 2 pi is 0, then minus of, then again if you put pi here, minus pi into cos pi, which is minus 1, sin pi is 0, of course. So let's simplify this. Minus pi into minus 1, 1 pi here, minus of minus plus 2 pi, minus of minus plus, again this is plus, of course, so 1 more pi, so total it is 4 times pi, of course. Okay, so therefore integral 0 to 2 pi mod x sin x dx is equal to 4 times pi, of course. Okay, so what is the value of this k? It is 4. That's all. So if you have entered 4, it would definitely the correct answer. Okay, so let's check. Oh great, but only one of you have answered. Okay, within the time, means the others has not solved it. Okay, so integration of cos x minus cos x is minus sin x. Correct. Integration of minus cos x is minus sin x, but there is one more minus which is here. See, eventually what I have done is, look, there is a plus here. Here what I have done is, it is minus of minus sin x. Okay, so this minus of minus I have written as plus. That's it. Okay, Seven, clear? This minus of minus became plus. That's why I have taken a plus sign here. Got it? Similarly, of course, the plus sign here is also in that way. Done? Yeah? Is this clear to all of you? So the answer is 4. Please repeat how negative term come. Where? This one. Okay, when this function inside the modulus is negative, then ultimately mod of that function is actually negative of that negative value. Okay, so here this x sin x is negative, right? So if modulus function has to be positive, this modulus outcome has to be negative of negative function. So total this complete bracket is positive then. That's how. Like if you want mod of minus 5, you know it is 5. How did you write 5? Because since this number is negative, negative of this negative number, which gives you 5. Similarly, if this is negative, then negative of this complete negative, which give you whole positive. That's what. Okay, fine. Is this clear to all of you? Did you all understand why it's 4? It's a previous gate question actually. In YouTube, basically I'm solving a previous year gate questions so that you'll have enough idea. And actually PYQs are very important. Okay, fine. I've given you one more question. Let's solve it. The area enclosed by the curves, the area enclosed by the curves y equal to sin x, y equal to cos x, x is equal to 0, comma x is equal to pi by 2 is dash. I think I have asked you to round off to 2 decimal places maybe. So what is the answer again? Enter. Oh, something happened. Yes. Just a second. This got hidden, I guess. Where's the poles? Pole has escaped somewhere. Just a minute. Maybe I'll start again. Okay, better. So, okay, good. So solve this question. If you have solved, then enter the answer to 2 decimal places maybe. 2 decimal places is what I think I have asked. So please enter the answer in 2 decimal places. 0, is it? Okay, fine. Quick, a bit faster. 0.5857 maybe. Fine. Okay, so let's solve this question. First of all, I have given you the way to calculate this in the last class. Let's see. If this is x-axis and if this is y-axis, y, x, of course, okay, then x is equal to 0 is nothing but this y-axis, is this axis, of course, x is equal to 0, x equal to pi by 2 is somewhere like this, x is equal to pi by 2 is somewhere like this, then y is equal to sin x, starts from 0, goes till here. Okay, so let's say this value is 1. This value is 1, of course. So this value is 1, and y equal to cos x. So cos x is something like this. Y is equal to cos x. Y is equal to sin x, of course. Okay, x equal to 0 to x equal to pi by 2. Now, I want to ask you one thing. Here you have 4 regions, 1, 2, 3, and 4. Now, out of these 4 regions, can someone tell me which regions I should consider? If I want to calculate this area, which is enclosed by those curves between x equal to 0 and x equal to pi by 2, out of these 4 regions, which regions I should consider? I have written 1, 2, 3, 4. I have to consider 4. Okay, maybe 4 I have to consider. Yoga Anthony. Okay, still any other answers that someone want to mention? 4. Okay, let me tell you one thing. If you write these equations once, given curves are y equal to sin x, y equal to cos x, x is equal to 0, comma x equal to pi by 2. Correct? Now, can someone tell me this x-axis, is it present in these curves? What is the equation of x-axis? Basically, y is equal to 0. Correct? This is the equation of x-axis. Is y equal to 0 present in these curves anywhere? Is y is equal to 0 present anywhere in that curve? This x-axis is given by y equal to 0. Out of these 4 equations, can you find y equal to 0 at any point? Come on, tell me. Can you see y equal to 0 in these equations? Yes or no? Yeah. No, right? Obviously you cannot see, right? So this x-axis we have drawn just for the reference, but this x-axis is not, we are not interested in the problem. So the actual area that is interested is, that is of interest is this area which is bounded and this area which is bounded, of course. Okay, so these are the 2 areas which are of interest. Okay, now let's see. So the point of intersection of these 2 is somewhere, you know, this is pi by 4. X is equal to pi by 4. So if x is equal to pi by 4, then if you want the area, you may call it A1 and you call this A2. So area bounded area bounded is A1 plus A2. Now let's see, in A1 means within this region, the upper curve is actually y equal to cos x and the bottom curve is y equal to sin x. Okay, so integral x is equal to 0 to x is equal to pi by 4. Why I am splitting at pi by 4? Because at pi by 4 those two are crossing each other. So till this point cos x is on the top and sin x is on the bottom, but once it crosses pi by 4, sin x goes up and cos x starts falling down. Okay, so that's why 0 to pi by 4 cos x minus sin x dx plus, now from pi by 4 to pi by 2, what's happening? Pi by 4 to pi by 2 sin x minus cos x dx. This is what you have, of course. Okay, so this integration actually gives you that area. See, when you are calculating areas bounded between the curves, you have to keep two things very importantly. First thing, what is the area that we are interested in? Okay, many of you might have felt it is 4, but actually this area is not bounded. Okay, because this equation is not given in this 4 equation. So obviously this line is not a boundary for the area what we want actually. Okay, this x-axis we have drawn just for reference, otherwise this is not a boundary. If this is not a boundary, this is not a finite area, it's infinite. Okay, so the areas which are actually bounded is this and this, of course. Okay, so 1 and 3 are the areas. This is first point. So which areas you should consider? Second, within that area, is there any intersection of the curves and is the curves crossing each other? Okay, so because if curves are crossing each other, you can see this cos x and this sin x are actually interchanging their positions after this x equal to pi by 4. So you have to break the integration at pi by 4, because I told you integral a to b f of x minus g of x dx is valid only when this f of x is greater than or equal to, of course if it's equal to, it's 0. So f of x greater than g of x. Yes or no? Now till this point this f of x is cos x and this g of x is sin x, but after this point sin x takes a leap, so sin x minus cos x is what you have here. Okay, fine. Kushwant Singh Sakya, sorry, this channel is dedicated for English learning, so it's okay, try to learn. Okay, no issues. ठीक है, क्योंकि मान लो कि आपने किसी इंटरव्यू पे गया था PSU के लिए, लेकिन और इस ODRDO में नौकरी मिल गया, अब बोलते हैं क्या तो हिंदी प्लस इंग्लिश में बताओ, है ना? सो थोड़ा सा learn. Even I'm not against Hindi or English or Telugu or whatever, but I'm just telling you, please try to learn English. Okay, because ultimately the final gate paper is going to come only in English. Okay, that's the reason. Hello, fine. So did you understand why I have split this integration? So two things you have to keep in mind is always whether what is the area interested, and second, what are the curves which are on the top and bottom. If they are interchanging, you have to break the integration at that point. Okay, so these are the two things you have to keep in basically back in your mind to think to do this integration. Now is it clear to all of you why I have given this area bounded A is equal to this integration? Fine. Is this okay to all of you? Did you all understand why I have split the integration at pi by 4 and I have written cos x minus sin x in this part, and in this pi by 4 to pi by 2, pi by 4 to pi by 2, why sin x minus cos x I have written? Is this okay to all of you? Each and everyone. Yeah, see, I have given you some nice questions so that if you have thought these points, you would have got very high clarity on these concepts. Okay, so let's solve this. Now if you solve this, A is equal to integration of cos x minus sin x. So integration of cos is sin, integration of minus sin is plus cos, because minus of minus cos. So this is the value between 0 to pi by 4 plus then sin x integration minus cos x minus sin x within pi by 4 to pi by 2, of course. So if you simplify the values, so pi by 4, 1 by root 2 plus 1 by root 2 minus sin 0 plus 1, of course. Okay, so this is the value. From these two terms I am taking minus out common. So cos x plus sin x is what you have, sin pi by 2, I mean cos pi by 2 0 plus sin pi by 2 1 minus cos pi by 4 plus sin pi by 4 actually. So if you simplify this, 1 plus root 2 by 1 plus root 2, it is total 2 by root 2. So this value is root 2 minus 1 minus 1 minus root 2 again here. So this is basically 2 times of root 2 minus 1.828 is what you have the exact answer. Okay, because root 2 is 1.4, so 1.414 minus 1, 0.414. So 0.414 into 2 gives you 0.828. So if you round off to 2 decimals, it's around 0.83 is what you have the answer, of course. Okay, so 0.83 units. And if you observe one thing, Since this sine and cos are symmetric about this line, so both these integrals will give you same value. So this is √2 minus 1. This value is also √2 minus 1 in terms of magnitude. So obviously here this is symmetric about the line x equal to pi by 4 clearly. So this area and this area would be same, which eventually is proven by the value of these integrals being equal. Okay, nice. 0.83 is the actual answer. Some of you wrote 0.57 something, but yeah, one of you has written 0.57 something, but actually 0.83 is the correct answer. Okay, everyone please type in the chat box, is this clear to you? Durga, Steven, sorry, 7 stars, Shravan, Pushwan Singh, Vishwaranjan Mishra, Arvind, Ashwini Kumar, Viswal, Pranay. Of course I could see only these names, just have escaped. Okay, so did you all understand? I'll give you one more question, one last question, and I'll give you time, so please think about this. The area bounded by the curves, the area bounded by the curves y equal to sin x, y is equal to 0, means basically x-axis, which is x-axis, x is equal to 0, comma x is equal to 2 pi is dash. Come on, do this question. I'm giving you time actually. So for this question 0.83, I think none of you have done it maybe, but yeah, that's the way to do that question. Now to solve this question, I'm giving you say 120 seconds. Yeah, good enough. Come on, solve this question quickly. Yeah, I understand, because people are tempted to take region 4 in that. Okay, but because x equal to means x-axis, which is y equal to 0, is not a boundary. Okay, come on, do this question. Hi Ashwini, for every question answer is 0. How come? One. Okay, maybe. Four. Good. Okay, so let's write the given data. Meanwhile, poll will end. So let's see if you plot these curves. So given curves are y is equal to sin x, x is equal to y equal to 0, which is basically x-axis, x is equal to 0, x is equal to 2 pi. Now, so the poll got ended, right? Okay, poll ended. First point, I want to ask you something. How many of you calculated and got the answer as 0? Tell me. You should be honest. Okay. So how many of you have calculated the integration and got the answer to be 0? Definitely there will be people, I know. But please tell me, how many of you have got this 0 as the answer after solving the integration? Integral 0 to 2 pi sin x dx 0. How many of you have got this? Okay, you're shy enough to not to reveal. Good, fine. It's okay. So let's see, if you plot these curves, let's see what you get. This is okay. I'll slightly extend this. Fine. So let's see, origin, x-axis, y-axis. So if you plot sin x curve in general, so let's say you have got something like this. Okay, so you got something like this. Then let's see So this is 0, x equal to 0 ultimately. This is x-axis, which is y is equal to 0. This is y-axis, which is x is equal to 0, and x is equal to 2 pi is somewhere here. Okay, so x is equal to 2 pi. That's what you have. So let's see, from x equal to 0 to x equal to 2 pi, the area which is bounded by this curve, this is y is equal to sin x, is, this is area 1 and this is area 2. So area bounded is equal to a1 plus a2 again. Okay, so let's say, now in general, if you want to do this, I'll show you two methods to solve this question actually. The first thing is, you want 0 to 2 pi, but this angle, this x value is here pi, this. Okay, so from 0 to pi, out of sin x and x axis, which is on the top, please tell me. From 0 to pi, this is y equal to sin x, this is y is equal to 0, of course. Then out of sin x and 0, which is on the top, actually clearly sin x. Okay, so 0 to pi, sin x is on the top, minus y equal to 0 dx, plus from pi to 2 pi, the curve which is on the top is 0, so 0 minus sin x dx. This is what you have, of course. Okay, because from 0 to pi, sin is positive, obviously, so positive values are more than 0, so sin x will be on the top than this x-axis. Okay, similarly from pi to 2 pi, sin is going to be negative, so obviously 0 is actually more than sin x values. Okay, so that's how you have. So this is 2 pi, of course, 2 pi. So if you simplify this, integral 0 to pi sin x, so sin x integration is minus cos x within the limits 0 to pi, minus integration of sin x is again minus cos x, so minus of minus is plus cos x within the limits pi to 2 pi, of course. So if you simplify this, minus of cos pi is minus 1, minus of cos 0 with a minus sign is minus 1, of course. Okay, so plus, what is this value then? Cos 2 pi, 1 minus cos pi is minus 1, so total this is 4, of course. Okay, so this value is 4 finally. So the value is 4 in this case. Now you can also, so basically if you do this technique, you'll get the answer 4. I would tell you one more way to get this answer 4. So first of all, by looking at this, and normally if you know the sine graph, can you say a1 is equal to a2? Yes or no? Correct? Because it is symmetric. Clearly whatever is this area, same would be this area, because sine is actually symmetric about this line. Okay, then in such case, total area can be written as a1 plus a2, which is equal to 2 times of a1, of course. Okay, so 2 times of a1. This is what you can do. Once you get this, so again, this area a1 is symmetric about this line x is equal to pi by 2, correct? So this line x is equal to pi by 2. So if you take this area, this total a1 is exactly 2 times of this shaded part. So this can be written as 2a1 can be written as 4 times of shaded area. 4 times of shaded area, which is something like 4 into integral 0 to pi by 2 sin x dx, and the curvature area from 0 to pi by 2 is 1, so this is 4 again. So that also one more way to solve this question actually here. Okay, so that's how you have to think a bit when you're trying to plot the area, when you're trying to calculate the areas which are bounded by the curves, of course. Okay, then I'll give you one last question basically to solve. The area bounded by the function y equal to mod x, bounded by the curves y is equal to mod x, x-axis x is equal to minus 7 to x is equal to 4 is dash. Come on, solve this question. So the answer is 4 again. I think Pranav has done it. Yeah, good. So integer type. So here also I'll give you again 120 seconds. Yeah, good enough. Solve this question. There's a mod x function and x-axis is bounding, and x equal to minus 7 minus whatever, minus 7 to 4, of course. Do this question. 0.25 maybe. No, answer would be definitely more than 6, 100%. No, 8, more than 800%. What would the answer? Let me calculate. Yeah, I got the answer. Okay. Nobody? Fine. So the answer is 32.5. Let's check. Let's try to edit if it's wrong, maybe. So let's solve. How I confidently told it is, what many of you have tried is, clearly you know mod x is positive. So area bounded is equal to integral -7 to 4 -7 to 4 mod x dx. So ultimately, you know, this mod function is not differentiable at x equal to 0. So you should split this integral -7 to 0 mod x dx plus integral 0 to 4 mod x dx. This is what many of you have understood. Okay. So clearly now one can say that this -7 to 0 x is negative. So mod function is -x. So -7 to 0 minus x dx plus integral 0 to 4 mod x dx. Okay. And if you integrate this, minus x square by 2 minus x square by 2 within the limits -7 to 0 plus x square by 2, because you know basically from 0 to 4 this mod x is just x, because x is positive, so mod x is x as well. So integration of x is x square by 2 within the limits 0 to 4. So if you simplify this, you can see -1 by 2 into 0 square, which is 0, minus -7 square is 49, plus this guy 1 by 2 times of 4 square 16 minus 0 is 0. Okay, so minus of minus 49, 24.5 plus 8, which is 32.5, of course. Okay, so that's the correct answer, 32.5. So 32.5 is the actual answer. So of course none of you have solved, but so this can be easily done in 2 minutes, hardly 3 steps, 1 2 3, and it's a bit of calculation. But you can also do this question in another way if you just know geometry. Look, this is x axis and this is y axis. Anyhow, mod x is positive, so I'm not worried about negative y, sorry, x minus x y. So if you now plot the mod x function, the mod x function would take this form. Okay, so this is y is equal to mod x, of course, which you have seen. I have plotted many times and shown you. Now, what is the area that is bounded? The area bounded by the function mod x, x-axis, between x is equal to -7. So x equal to -7 is somewhere like this. Okay, so this is x is equal to -7, for example. X is equal to 4. So let's say 4 is somewhere here. X is equal to 4. X is equal to 4, of course. Okay, then the area bounded is nothing but area of these two triangles. So no, if I call this to be A and this to be B, this to be C, and this to be D, of course, then in such case the area bounded is geometrically equal to the area of these two triangles, correct? A1 and A2. That's it, right? Done. Okay, so if this length is 7, because it is 0, it is x equal to -7, so ultimately this OB length is 7 units. Okay, so this is 7 units. If this is 7 and if this is a line y equal to -x, what would this height? It is also 7. Okay, similarly if it is 4, this height would also be 4. So area is equal to A1 plus A2. So it's a rectangle, it's a right angle triangle, of course, with equal base and height. So half into 7 into 7 plus half into 4 into 4. So this first term is 49 by 2, which you got here, 49 by 2, and the second term is 8, which is the second term of the integration, and total value is 32.5. Okay, to do this you hardly need 1 minute if you think. Okay, so how 7 come? Because I have given x is equal to minus 7. So x equal to minus 7 line is this. So this length is 7. If this length is 7, then ultimately, since this is the point on the line y equal to minus x, this point will have the coordinates minus 7 comma 7. So this height is also 7. That's all. Clear to all of you? Yes or no? Please type in the chat box. Is this clear to each and everyone? Yes or no? Clear na? Now you tell me to do this how much time it takes. Hardly 30 seconds. That's what. Hello. Let's now teach a bit of story again. Then let's. Okay, one more question I'll give before we go forward. Solve this question. The value of the integral 0 to 2 pi. Again, based on the properties that we have discussed. Integral 0 to 2 pi 3 by 9 plus sine square theta d theta. Come on, do this question. So I'll give single choice, and how much time you need? Okay, take 2 minutes. No issue. Solve. What is the value of this integral? Integral 0 to 2 pi. All these questions are PYQs. Okay, get previous year questions. But of course in different branches. On, do this question. Try to use one of the properties that I have told you in class. Okay. A, B, okay, fine. So that's why attending classes continuously is very important. Okay, so let's check what would be the value. So can I write this as I is equal to twice integral 0 to pi 3 by 9 plus sine square theta d theta. The reason is this function sine square theta is same as sine 2 pi minus theta whole square. Okay, because practically this sine 2 pi minus theta is minus sine theta, of course. Okay, but when you put a square on the top, ultimately this again becomes sine square theta, of course. Okay, so which means if you remember, I have given you one property, integral 0 to 2a f of x dx is same as 2 times integral 0 to a f of x dx if f of 2a minus x is equal to f of x, right? I have given you one property. So as per that, I can write this 2 here and you can multiply it here. Now let's see. So this is step 1. So hardly 5 seconds if you know that. Then I is equal to, I am pulling out this 3 out. So 6 into integral 0 to pi d theta upon, now this 9 can be written as 9 cos square theta plus 9 sin square theta, and 9 sin square theta plus sin square theta, total it is 10 sin square theta. That's it. Okay, so for this I have given you the result already. So integral 0 to pi d theta by 3 square cos square theta plus square root of 10 whole square times sin square theta. So this value is 6 into pi by AB, of course. So A is 3, B is square root of 10. So this is 2 pi. So the answer is 2 pi by square root of 10 actually here. Okay, so the I value is 2 pi by square root of 10, which is option A. Yeah, many of you have done. but not within the time, because to write these 2-3 steps it hardly takes 1 minute maximum. Okay, so A is the correct option. Let's see if some of you have written. Nice. Pranav and Pushpan Singh Sakya. Nice. Good. So chalo. Fine. So let's again learn some concepts. We have solved some good number of questions. Length of a curve, actually. Length of a curve, of course. So how do we calculate length of a curve? Let's say. So let's say, for example, you have some thread like this. Then how do you get this length physically? Normally, let's say you have some shape like this, okay, some curve like this. Then how do you get the length? Normally you put one end of the thread here, then arrange thread along this curve, take these two ends, make it straight, put it on a scale, you will get the length. Okay, this is the way how you physically get the length, of course. Basically how you get, to take a thread, put one end here, arrange the thread along this curve, then take these two ends, make it straight, put it on a scale, you will get the length. Okay, so this is one way of doing it. But mathematically, how are you going to do it? Okay, so let's check. So first of all, let's establish a coordinate system to do the analysis. This is origin, this is x, this is y, and let's say this point is x is equal to a, and this point is x is equal to b, of course. Okay, so x is equal to b. Then this is some function y equal to f of x, which fits approximately like this. Okay, so y is equal to f of x. So how to calculate length of this function y equal to f of x between x equal to a and x equal to b? That's the story. Now let's see if f of x is continuous. Of course, it should not break. F of x is continuous in y is equal to f of x is continuous in x belongs to a comma b, let's say. Then the length of the curve, then the length of the curve between x equal to a and x is equal to b is given by L. If I call this length as L, then L is equal to integral x is equal to a to x is equal to b root of 1 plus dy by dx whole square, which would also be same as integral if this value is y equal to c and if this value is y is equal to d, this integral would have also been equal to y is equal to c to y is equal to d root of 1 plus dx by dy whole square times dy actually here. Okay, so this you can use any of these two formulas, you'll get the same answer. Okay, so let's see how do you get these formulas. It's a simple job, actually, nothing much complicated. See, if I take a small portion of the curve, okay, I have taken small portion and I have taken this length as dl, of course. Okay, so I have taken a very small portion. If I have taken very small portion, it's something like this dl. I'm enlarging it to show you something. Now if you project this, ultimately this length would be dx and this length would be dy, of course. Okay, now if you approximate this curve, which is, see, like for example you have a curvature here, but if you take a very small length and zoom it, then you won't see the curvature. It's like earth appears flat. Okay, but of course it is actually a circular, basically spherical in shape, and you won't be able to see the curvature, of course. Okay, so similarly when you go to a very small distance, if I connect these two with a straight line, so let's say if I connect these two with a straight line, you can't find much difference between the straight line and the curvature, actually. So what we can assume is this dl square is almost equal to dx square, because this is a right angle, so dx square plus dy square from Pythagoras theorem. So can you do this? The approximation I have done is I have picked a very small length dl and I have taken the projections of dx and dy and I am applying the Pythagoras theorem. That's it. Okay, is this clear to all of you? Please type in the chat box. Is this okay to each and everyone? Did you all understand how I'm making this assumption? It's a very small part, so the curvature or the straight line doesn't make big change in length, of course. Okay, yes. Now therefore dl square is equal to, let's neglect the variation, dy square, of course. So this tells you dl, the small elemental length, is equal to root of dx square plus dy square is what you get. Okay, so the small length is dx whole square plus dy whole square under square root. So therefore total length between a and b, total length between x is equal to a and x is equal to b is L is equal to integral dl. Now if you want to integrate dl, how you can integrate? Let's do. You can take dx square common from this. If you take dx whole square common, you'll get 1 plus dy by dx whole square times dx, of course, correct? Because from this two terms, if you take dx whole square common, first term will be 1, second term will be dy by dx whole square. So the value under the square root is this. So into root of dx whole square, so this becomes dx, of course. Then the integrating variable becomes x, obviously. So this is the integrating variable. So x is equal to a to x is equal to b is what you have, of course. Or if you want to take dy common, if you take dy common, L is also equal to integral dl. If you take dy common, then you have dx by dy whole square plus 1, or maybe I can write it as 1 plus, sometimes it's comfortable to integrate this, dx by dy whole square, and this multiplied with dy, of course, and y is equal to c to y is equal to d. You can apply any of these two formulas, you'll get the answer, of course. Okay, so let's try to do one thing. Basically, you all know, if you take example, let's work out an example. Length of the curve x square plus y square is equal to, say, a square. Yeah, okay, a is fine, you take a square, between x is equal to 0 and x is equal to x is equal to a in first quadrant. Let's say in the first quadrant we are talking, in the first quadrant. Okay, so if you talk about in the first quadrant, then let's see. So basically we all know that it denotes a circle. If you plot origin x y, of course, and if you plot the curve, let's say this is x square plus y square is equal to a square, and this, let's say, since in the first quadrant y is positive, y is plus root of a square minus x square. Okay, because in the first quadrant y is positive, you know this. So we all know that if this radius of this circle is a and it's only 1/4 of a circle, then the value of perimeter is pi times a by 4, sorry, by 2, of course. Okay, because for complete circle it is 2 pi a, and for complete circle if it's 2 pi a, then 2 pi a divided by 4 gives you pi a by 2. So that this length is actually equal to pi a by 2. So now let's apply this procedure and let's check whether we get the value or not. Okay, so clearly this is x is equal to 0 and this is x is equal to a. Okay, so let's calculate the value. So L can be taken as integral x is equal to 0 to x is equal to a root of 1 plus dy by dx whole square times dx, of course. Okay, now what is dy by dx? Let's see. Y is equal to root of a square minus x square. So this implies dy with respect to x is minus 2x by 2 root of a square minus x square. So ultimately 2 gets cancelled. So this value is minus x by root a square minus x square. So this is what you get actually here. Okay, so minus x divided by root of a square minus x square. Now let's substitute this dy by dx here. So L is equal to integral x is equal to 0 to x is equal to a root of 1 plus dy by dx whole square. So square of this complete thing would give you x square by a square minus x square dx, of course. Okay, so that's what you get. 2. So basically you will get integral x equal to 0 to x equal to a root of 1 plus x square by a square minus x square dx, of course. Now if you simplify this, the thing under the square root, x is equal to 0 to x is equal to a, of course. If you take LCM, a square minus x square, so x square and x square gets cancelled, so you will eventually end up with a by root of a square minus x square dx, of course. Okay, so that's the function what you get. So if you take a out as constant, a into integration 1 by root of a square minus x square. I have already taught you this. This gives you sine inverse of x by a, correct? So sine inverse of x by a within the limits x equal to 0 to x equal to a, of course. Okay, so everything is going fine. So sine inverse of x by x by a. So if you put these values a into sine inverse of if you put x equal to a, sine inverse of 1 is pi by 2 minus sine inverse of 0 is 0. So the answer is pi a by 2, which is in this case. Okay, so pi a by 2, of course, and which we eventually know because it's 1/4 of a circle. So pi a by 2 would be the value of this circumference of 1/4 of a circle, which also the same value from this integration. Okay, so pi a by 2. So that's how you can use any of these two things. Clear? In general, I would have used y equal to 0 to y equal to a, then dx by dy whole square. Obviously here it is symmetric. If you replace x or y, it doesn't matter, but in general you can do that. Okay, fine. So is this clear to each and every one of you? Yeah. So everyone, please type in the chat box. Is this fine to each and everyone? Can you compare that this value and this value is same by doing this integration? Okay, so let me give you one question now to deal with. Come on, do this question. The length of the curve y equal to 2/3 x power 3 by 2 between x equal to 0 and x equal to 1 is dash, round off to 2 decimals. Do this integer type. So 2 minutes I am giving you. Enough. Yeah. All. What is the meaning of 𝐂𝐨𝐿𝐻? I have not heard actually. 𝐂𝐨𝐿𝐻. I have never heard. This is the first time I'm looking. Yes. Maybe I'll Google it and tell you. Come on, do it quick. Only half an hour more left. OF Wanker. No. Wankel. Oh yeah, Ashwini. Why are you guessing randomly? First try to attempt, no? Try to solve the question. Spend some time. GATE exam is not about sitting in front of the system for 3 years and entering random values and clicking a random option. Okay? They have to work out something. I'll have water meanwhile. Point 36 maybe. Fine, let's see. I don't have much clarity. Let's solve this. So what's the curve? It's a PYQ as long as I remember. I think once this was asked in ISRO exam as well. So length of the curve y equal to 2/3 x power 3 by 2 between x equal to 0 and x equal to 1. Okay, so let's see. Given y is equal to 2/3 x power 3 by 2. So what is dy by dx? Root x, correct? Yeah, of course. 2/3 into derivative of x power n is n into x power n minus 1, which is this. Okay, so 2, 2, 3, 3 gets cancelled. So this is square root of x. So this implies L is equal to integral x is equal to 0 to x is equal to 1 root of 1 plus dy by dx whole square. Okay, I'll write this formula once. Dy by dx whole square dx, which tells you x equal to 0 to x is equal to 1, of course. Then root of 1 plus dy by dx, which is root x whole square, is x dx. So x is equal to 0 to x is equal to 1 plus x whole power 1 by 2 dx. So many of you stopped at this point, correct? Because you guys don't know how to integrate this. So it is nothing but just 2/3 times 1 plus x whole power 3 by 2. Same thing. Between the limits x equal to 0 to x equal to 1. So 2 by 3 times of. So if you put x equal to 1, it is 2 power 3 by 2. Minus if you put x equal to 0, 1 power 3 by 2. Obviously. So it's like 2/3 times of, this is 2 to minus 1. So what is 2 to minus 1? This is 2 into 1.414, 2.828 minus 1, so 0.828. Okay, we have a calculator, why to put so much struggle? 2 into 0.828 divided by 3, 0.552. Is it 2 root 2? Okay, so 2 times of square root of 2, which is 2 into 0.828, so 2 1.414, so 2.414 minus 1.828, sorry, this is 1.828, not 0.1.828. So 2 into 1.828 divided by 3, 1.2186. So if you round off to 2 decimals, this is 1.22 is the actual answer. Okay, so 1.2. Okay, fine. So let's solve this. So this is 1.22 actually here. Then let's get back to this theory. So let's solve certain things. Polar coordinates is what will work out. Polar coordinates. Okay, so let's see how we actually do things in polar coordinates. Of course, okay, polar coordinates. So let's see this. Normally if you have a curve, so let's say this is some function, you have some function like this, for example. So this is y is equal to f of x, so this is x and this is y. Okay, so ultimately it tells you once you keep changing the values of x, then the values of y keep changing up. Okay, then the same thing can also be mentioned as, this function can also be mentioned as r is equal to some function of theta, of course. Okay, so radius is basically some function of theta. Means in general, if you spot a point here, say the coordinates of this point are x comma y, of course, then ultimately you know this length is x and this length is y. Similarly, if you know, if you can plot a point with the help of x and y, you can also denote the same point using this coordinate system r and theta. Okay, so once you define r value and theta value, you get a unique point on the coordinate plane, and this x comma y can be represented with this r values and theta values, of course. Okay, so if you now compare, if this angle is theta, if this side is x, then this side is also x, of course. So x is equal to r cos theta and y is equal to r sin theta, of course. Okay, so y is equal to r sin theta in this case. Okay, so x is r cos theta and y is r sin theta. Now let's see if you, and ultimately this r value is square root of x square plus y square. Normally the conversion for polar coordinates is tan inverse y by x. Okay, so these are the way, this is how the variables are connected between x and y. So clearly x is function of r and theta, y is function of r and theta, or in general r is function of x and y, theta is also function of x and y, of course. Okay, so if you want to calculate the lengths, how could you calculate? Okay, so in polar coordinates, if you want to calculate, how can you calculate? Let's see here. So let's say this, if you want to calculate between these 2 points a and b, of course. Okay, so you want to calculate this length, then ultimately this point which is here makes an angle theta 1 and this angle makes theta 2, of course. Okay, and r changes according to theta as usual. Is this clear to all of you till this point? Can you all first recognize that any point on the 2D plane can be represented in terms of even polar coordinates like r and theta, where the variables are connected in this particular fashion? And if you want to identify this point to this point length, it is basically when theta 1 and theta 2. So the curve is basically changing its position from theta 1 to theta 2, and r changes accordingly because r is some function of theta actually. Okay, then let's see, when you have x is r cos theta and y is r sin theta, of course. Okay, So clearly let's see, x is function of r and theta. So if you want dx can be written as, normally there is something called chain rule of differentiation, which we'll deal again in detail, in much detail, when we talk about vector calculus and also in multivariable calculus, okay, in the upcoming chapter. So but first of all, I'd like to tell you something. If f is equal to some function of x comma y, then this implies df, if you want to calculate the change in f, it is actually equal to dou f by dou x into dx plus dou f by dou y into dy is what you have. Okay, so this is basically the chain rule of differentiation, and we'll talk about the physical meaning of this when we talk the multivariable calculus, but right now just keep it mathematical. Okay, so chain rule of differentiation, chain rule of differentiation, of course. Okay, so chain rule of differentiation. So now clearly this x is, so you know, L is equal to integral dl, which is integral root of dx whole square plus dy whole square, of course. Okay, now depending on what you take common, the value, the integral will have the limits either in terms of x limits or basically y limits actually. Okay, so let's see, if x is function of r comma theta, x is function of r comma theta, which is r cos theta, of course, can I write dx is equal to dou x by dou r times dr plus dou x by dou theta d theta. Can I write this? Because as per this chain rule, if any function is depending on in general any number of variables, this df can be written like this. So here x is depending on r and theta, so dx can be written as dou x by dou r into dr plus dou x by dou theta into d theta as per this chain rule. Okay, then what is dou x by dou r? Basically, I hope you have some little bit idea about the partial differential equation, partial differentials. So this dx value is equal to, dx is equal to, what is dou x by dou r? So when you are differentiating partially with respect to r, of course I would have gone much details about this partial derivatives in the next class, but since you have some basic idea, I'm dealing. So this dou x by dou r, when you are differentiating with respect to r partially, this theta term is constant, so cos theta is constant, so cos theta into differentiation of this r with respect to r is 1 times dr plus dou x by dou theta. So if you are differentiating with respect to theta partially, then this r is constant, and derivative of cos theta is basically minus sin theta times d theta, which means you have dx is equal to cos theta times dr minus r sin theta times d theta, of course. Okay, so this is first equation, maybe I can call this equation 1. Okay, then if you convert to basically the second variable, you know, y is equal to r sin theta. So similarly, if you do dy, you will get dy is equal to dou x by dou r, so dou y by dou r, so sin theta into 1 times dr plus, with respect to theta, if you differentiate, r into cos theta d theta. This is what you get. So this is 2. But now the term which you are interested is dx square plus dy square actually. Okay, so therefore dx whole square plus dy whole square, if you convert to polar and if you simplify, if you square this right hand side and add this, look, basically if you square this term, the first term would be cos square theta dr whole square, and here it would be, it's looking like percentage, sorry, sin theta into dr, 1 into dr, of course. Okay, so let's see, if you square these two terms, let's look at the simplification. It's a bit of pure algebra. So cos theta whole square dr square plus sin theta whole square plus dr square. So if you take dr square common, you would have left with cos square theta plus sin square theta. Okay, plus sin square theta, of course. Okay, this is what you would have left with. Next, p square terms. So this term would be r square sin square theta d theta square, r square cos square theta d theta square. Okay, so which means if you look carefully, you have r square d theta whole square into again cos square theta plus sin square theta is what you get. Now going to the 2ab terms. Okay, so 2 into r cos theta sin theta dr d theta plus 2 into r dr cos theta sin theta d theta, which means the 2ab term in this and the 2ab term in this will cancel up each other. Yes or no? Because of this minus sign and plus sign here. So the product, see, r is present here, cos theta is present here, sin theta is present here, dr is present here, d theta is present here. So if you multiply these 2ab terms, this minus 2ab and plus 2ab will actually cancel each other because obviously the terms are same. So clearly this value is 1 and this value is also 1. So therefore length of the curve in polar coordinates is equal to root of integral root of dx whole square plus dy whole square, which eventually gives you, so square root of, now let's see, ultimately this complete thing can be written as r square d theta square plus dr whole square. Okay, that's what you get. Now if you simplify this, if you take d theta common, you will get root of square root of r square plus dr by d theta whole square times d theta. So ultimately the value of the limits is from theta 1 to theta 2. So this is in polar coordinates, basically how you calculate the length of the curve. Okay, so it's clear. So if you write this value, therefore length L is equal to integral theta is equal to theta 1 to theta is equal to theta 2 square root of r square plus dr by d theta whole square d theta, of course. Okay, now if you try to do the previous question using the same in polar coordinates, because circle is one figure where you can easily use polar coordinates, of course. So if you try to use polar coordinates, let's see. So first of all, what is the equation of this? Center is at 0, 0, so r square is equal to a square is the value, of course. Okay, so let's see the equation or the length of the curve. The length of the curve r is equal to r square is equal to a square. Okay, so basically r square is equal to a square between theta is equal to 0 and theta equal to pi by 2. Okay, so this actually, if you plot the system, of course I'm just drawing Cartesian for reference, but if you take this curve something like this, okay, so this value is x is equal to, or theta is equal to 0 in this case, because this is the line in the initial line, and theta is equal to pi by 2, of course. Okay, and this function is given by r is equal to a square, or r square is equal to a square, of course. Okay, so r is equal to a in general with center at origin. Because why I'm writing r square equal to a square specifically is because if you have r is equal to a, okay, so people tell that you can square this and you can get x square plus y square is equal to a square. Okay, this is one way. Or some people convey this as r minus, I mean, if you multiply with r on both sides, you have a into r. Okay, so it's something like x square plus y square is equal to a into this r value, again splitting it and all will become slightly hectic. Okay, so that's why, because it again gives you root of x square plus y square, all these things. So that's why I'm just making sure that this r is equal to a is the circle. Okay, now then let's see. So ultimately this can be written as r is equal to a, and a is positive because it's on positive. Of course, radius is always positive at any given theta. It is always fixed. Okay, it's a circle. Now if you apply the same integration, let's see. L is equal to integral root of r square plus dr by d theta whole square times d theta, of course, and theta is running from 0 to pi by 2, of course. Okay, so theta is running from 0 to pi by 2 because your length, you're interested in calculating the length between this a to b, and eventually, you know, pi a by 2 is going to be the answer because it's 1/4 of a quadrant, 1/4 of a complete circle. Let's check whether this value is giving this or not. So L is equal to integral theta equal to 0 to theta equal to pi by 2 square root of r square. So r square value is a square on this curve plus dr by d theta. Now from theta equal to 0 to theta equal to pi by 2, r is constant. Okay, r is not depending on theta. Normally in few, not few, in all cases, if you have a general curve something like this, then r is depending on theta, of course. Okay, so r value changes from theta to theta, but in this case it's a constant value. So this dr by d theta is 0, of course. Okay, so r is equal to a is a constant, so dr is 0. Okay, so 0 d theta. So obviously, you know, this square root of a square is a times integral theta equal to 0 to theta equal to pi by 2 d theta, so which is a into pi by 2, which is this answer. Okay, so and you can see, compared to this integration and calculations, here the things are very simple, of course. Okay, within 1-2 lines you get. So that's why many times when the coordinate lines are along cylindrical or basically r and theta lines, r equal to constant and theta equal to constant lines, we choose polar coordinates, and things happen very simple in polar coordinates, when especially when you're dealing things like circular pipes or basically any circular shapes or spherical shapes, again you have spherical coordinates. Okay, so we have all these things which we eventually see when we go to we generalize this integration. Okay, so basically we can, now you have seen there is some conversion what I have done based on this dx whole square plus dy whole square summation, but in general without doing this you can directly convert an integral from Cartesian system to polar system without performing this dx whole square plus dy square, all these terms. Okay, there's some concept called Jacobian which we will see in multivariable calculus. Hopefully when we talk about multiple integrals I'll get that concept. There you will find much advantage of all these things. Okay, so you can see polar coordinates is very simple, of course. Okay, so that's why I have given you this. Then let's see the second, one more application is surface area of solids of evolution. Surface area of solids of evolution. Okay, so surface area of solids of evolution. So let's see, in such case, if you have a, for example, let's say you have a curve in the xy coordinate frame. Origin x, y. So let's say you have some curve something like this. Okay, maybe this is some curve, then this is y is equal to f of x. Now let's say if you evolve this curve, for example, about x-axis. Okay, so if you evolve this curve about x-axis, you will get a hollow solid. Yes or no? Correct? Like you will get a thin sheet, like in your first year workshop you might have done. It's a sheet with sheet metal, you will form different shapes. So if you revolve this curve about x-axis, you will get a surface. Okay, so what is the lateral surface area in such case? Okay, so let's see, if y equal to f of x between x equal to a and x is equal to b. So let's plot this to be x is equal to a and this to be x is equal to b, of course. Okay, so x equal to a and x equal to b is evolved about x-axis, is evolved about x-axis, then the surface area of evolution is a is equal to integral x is equal to a to x is equal to b 2 pi y times root of 1 plus dy by dx whole square dx. This is the actual expression in this. Okay, so y value is integral x equal to a to x equal to b 2 pi y times root of 1 plus dy by dx whole square dx. Now how did I get this expression? That's the question again. Okay, so let's see. So let's solve this. Origin x, y. So if you take a curve like this between x is equal to a okay, so let's say this is x is equal to a and this is x is equal to b, of course. F of x, x is equal to a and x is equal to b. Now let's say if you evolve this about x-axis, okay, then ultimately you'll get some surface. So what is the surface area? Look, if I evolve, I would get something like this actually. Something like this. Okay, so some solid of this form I would have got some surface. Okay, now if I want to calculate this, look, you take a small path here and let's say what is the area that you got here. Okay, so let's say if you take this path and if you revolve, what you would get is this is your x-axis, of course. So this is your x-axis. Okay, then here is what you have, and the surface that you get for evolution is, and the inside surface as well, which is basically. So you can see if you have a disc like structure, maybe I'll draw it very thin so that you all can recognize. Okay, so you all can recognize it. So you'll get a thin strip like area, and in this strip the surface that is mounted, this plus this surface. Okay, so I hope you can see now. Now at any given random point, the height of this curve is y. Okay, so let's say it is some random value of x what you have taken in between. So this is y and this is x, of course. Okay, so this height is y. Now if this height is y, ultimately it's like a disk that you form. Okay, so this is like a disk that you form, so this height is y. Then can someone tell me, if I want to calculate the surface area, if this small length is dl, of course, so this length is dl, and the circumference value of this is actually a circle, because if you take a point and if you evolve, you will get a circle. So this circumference is actually 2 pi y, of course. Okay, so because it is like a circle of radius y, so the circumference value is 2 pi y multiplied with this dl gives me the total surface on the top. Yes or no? Correct. So can you all understand that elemental surface area dA can be written as 2 pi y into dl, and dl we have just seen, this can be written as root of 1 plus dy by dx whole square times dx, of course. Okay, can I do this? Everyone, so please type in the chat box. Radhika, Durga, Anthony, Seven, Pushwan Singh, Sakya, all of you. Raman, every one of you, type in the chat box. Can I do this? Because if you want this surface area, like if you have a cap, for example, okay, so how do you calculate the surface area of any solid? Basically at that point, what is the side circumference multiplied with the length gives you the total surface. So can I get this? Please type in the chat box here. Can you understand this or not? If there is an issue, I'll talk back. Okay, so this is basically this small part when you evolved about x-axis. Okay, so if you take this small part and if you evolve this small part about x-axis, you'll get something like this. Okay, and on this the surface area is the part what I have hatched total. Okay, so in orange and also in yellow, whatever the hatched portion is there, that portion is the total surface area, I mean the lateral surface area of this. Okay, so let's say if you have a cylinder, how do you get the lateral surface area? Means basically how do you get this surface area, total surface area? You will take this length L, and obviously you know this circumference is 2 pi r. So this 2 pi r multiplied with this L gives you the total lateral surface area, correct? Similarly, if you want the lateral surface area of this disc, this circumference multiplied with this length gives me the lateral surface area of the surface, correct? Can you all get this now? Something similar. Okay, if I have rotated this and compressed, this is how I would have got. Okay, so the base circumference multiplied with height gives the lateral surface area. So similarly here, this base circumference multiplied with length. Okay, at this point, if you take this value as x, the height of this total length is y, because it's generally y equal to f of x. So at a given location x, this has a height y. So this is of height y ultimately, and when you evolve it, it generates a circle. See, for example, if you take a point, this final end point here, okay, and if you evolve this end point, then ultimately you'll get a circle, and the circumference of that circle is 2 pi y actually. Okay, so this is the circumference of this circle, and dl is the length, of course. So if you multiply these two, you'll get this total surface area of the wing. Okay, yeah. Okay, is this clear to all of you? Yes or no? Please type in the chat box. Yeah, ultimately this is the small elemental surface area. So if you want total surface, therefore complete lateral surface area, complete lateral surface area is A is equal to 2 pi y root of 1 plus dy by dx whole square times dx, and this is integral x is equal to a to x is equal to b, of course. Okay, or you can also get it as, if you evolve about y axis, then y equal to c to y equal to d 2 pi x root of 1 plus dx by dy whole square dy is what you would have got. Okay, so let's solve an example to get clarity on this. So example, so let's see, if you have this x axis and if you have this y axis, horizon x y, so let's say it's some part of a circle. Okay, then can someone tell me, if I evolve this circular arc about x axis, what is the surface I'll generate? What is the nature of surface I'll generate? If I evolve this about x axis, then what is the surface that I'll generate? Hemisphere, correct? So basically it gives you a hemispherical surface. So if I evolve this curve circle about this x axis, I will generate a hemispherical surface, of course. So yeah, means if I generate, I would get something like this, correct? And this is like a bowl, hemispherical bowl. Then what is the surface area of this hemisphere? Can someone tell me? If this is really a hemisphere and it's of radius a, what would be the area of the hemisphere? Surface area, lateral surface area of the hemisphere. So lateral surface area A is equal to how much? How does it rotate? We are rotating. Okay, we are evolving it about x axis. Normally if you have studied engineering drawing in your first year of BTech, there is something called solids of evolution. Okay, so you take a curve, normally which is called the trace, and if you evolve it about a particular axis, you will generate the solid. Like cone, if you want a cone, what you can do, you take a line y equal to mx and you evolve it about x axis, you will generate a cone. Okay, so these are traces of the cone. Similarly, like how you can generate a hemisphere, so it is 2 pi r square, correct? So this is 2 pi a square is what you get. Okay, so let's see, let's apply this formula, and see, it's not 3 because we are not considering this base. Okay, when you evolve this base areas are hollow, you don't have a surface there. Okay, so we have only the lateral surface. Now let's apply this formula and let's try to calculate that. So the curve is y is equal to root of a square minus x square, of course. Okay, so because y is positive in that range, so lateral surface area is equal to, normally LSA is lateral surface area, integral 2 pi y times root of 1 plus dy by dx whole square dx, of course. Okay, so between the limits x is equal to 0 to x is equal to a. Okay, because this curve is starting with this point here at x is equal to 0, and this is clearly x is equal to a, of course. Okay, so this is x is equal to a. Now if you integrate this guy, we have LSA is 2 pi into, that can be constant, can be pulled out of integration, 0 to a. What is the value of y? Y can be written as, so since y is positive everywhere in this curve, so y is equal to root of a square minus x square, of course. So square root of a square minus x square into root of 1 plus dy by dx whole square. So what is dy by dx? So this ultimately implies dy by dx is equal to minus x by root of a square minus x square. Okay, so that's what you have, because derivative of root is 1 by 2 root of a square minus x square into minus 2x, 2 gets cancelled, so that's the value. So if you do square of that value, you have x square by a square minus x square dx, of course. Okay, so let's simplify this values. Then 2 pi integral x is equal to 0 to x is equal to a root a square minus x square into, so if you simplify this value, if you take LCM, it's like a square minus x square plus x square. So this x square and x square gets cancelled. So square root of a square is a by root a square minus x square dx, of course. Okay, so clearly you can cancel this integral, this and this term. So if you cancel this, we have 2 pi into x is equal to 0 to a. This a is a constant, you can pull it out, dx. So this integration is one more a. So the answer is 2 pi a square, which is okay. So 2 pi a square. In fact, if you want, you can convert this in terms of polar coordinates as well. So how you can convert to polar coordinates? Let's see. The same integral in polar coordinates. In polar coordinates. Okay. So let's see. LSA is equal to integral 2 pi y, and in polar coordinates y is r cos theta times root of 1 plus, the length is r square plus dr by d theta whole square times d theta, and theta is going from 0 to pi by 2, of course. Okay, so this is the solid of evolution about this axis. So theta is going from 0 to pi by 2 actually. So if you do this integration, then let's see, r is equal to a is a constant in this curve. Okay, so in this curve r is equal to a, it's a constant, of course. So this is a, this term is 0, of course. So what we can do is, and r is equal to a, this is a. So if you write all these things, 2 pi can be pulled out, this a can be pulled out. Okay, then this is root of a square, so that is one more a, you can pull it that as well out. So you have theta is equal to 0, so theta is equal to pi by 2 cos theta d theta, that's all. Okay, so this is what you get basically, and this integration is 1, of course. Okay, so we can check, so how that integration is 1 basically. So 2 pi a square, integration of cos is sine within the limits 0 to pi by 2. So 2 pi a square times 1 minus 0. So 2 pi a square would be the area of the surface of this sphere. If you can identify the solid, then with the standard formulas that you can apply it as a trick, but in general this is the way how you calculate the areas. Okay, got it? This is in Cartesian, and of course this is in polar. It's just a coordinate conversion, nothing big deal actually, but I hope this is clear to all of you. Okay, fine. So we'll stop here for today. I'll give you some homework again. We'll continue one more lecture actually. So try this question, it's a nice question actually. I'll definitely conduct a poll tomorrow. Okay, the first thing I'll do is conduct a poll for this question, so please do this. So this is also a homework. This is also homework. Don't Google them, okay? Try to solve. You can solve with the knowledge what I gave you. So please solve these questions. Then we'll look at beta and gamma functions maybe tomorrow. We'll take one more lecture, no issue. So today basically we covered about applications of integration, definite integrals, in which we covered length, surface area, these things. Okay, so in tomorrow's class we'll also worry about volume, how to calculate the volume, of course, and then we'll also talk about the gamma and beta functions of. Okay, I have sent a doubt on Telegram, can you please reply? Yeah, now regarding this maths or something general doubt. If it's general, then definitely I'll look at. Okay, if it's maths, then we'll try to solve it. So fine, then we'll wind up for today. So tomorrow again we'll meet at 7 p.m. So we'll wind up this class of calculus, single variable calculus. Okay, maths. Then let me check, where's my phone? Okay. So let's solve. Some of us has some doubt in the Telegram channel. Telegram here. 7 stars. So could you please explain this problem? Linear algebra. Okay. So let's see. Consider the system. Consider the system of equations. Ax is equal to lambda. So let's see. We'll solve maybe one up here. So let's say there is a system a n by n. X is again this n by t system. So ultimately this gives you a system lambda of n comma t, where it's a scalar, is it? Where lambda is a scalar. So ax is equal to lambda. I think something is missing, right? Because if lambda comma xi be the eigenpair, then ultimately it should be like ax is equal to lambda x. Okay, so lambda into x n comma t. This should be the actual equation. Only then this lambda comma xi is the eigenpair. Okay, so a xi, if this is xi is the eigenvector, so this is lambda times xi for the corresponding lambda eigenvalue lambda. Then you can say, I think some part got missed here. So lambda I comma xi is the eigenpair which we have seen. Okay, so this is eigenpair obviously. Okay, where lambda I xi be an eigenpair of an eigenvalue and its corresponding eigenmatrix. Let I be n by n unit matrix. For which one of the following statements is not correct? For a homogeneous system n by n system of a minus lambda is equal to x. Obviously this implies a minus lambda I into x. I think we have directly solved this question. Okay, so this is a null matrix. This is a null matrix. Obviously having a non-trivial solution, the rank of det of a minus lambda I is less than n. Obviously this is 2. Okay, so clearly for this statement we have seen a system ax is equal to b, or basically ax is equal to 0 if you have homogeneous system. So ultimately if the system has unique solution, then that's the trivial solution, of course. Okay, so if this system has a trivial solution, then in such case the rank should be full. Okay, means a should be n by n, means if a is of n by n size, then the rank should be n, of course. Okay, but in general, if this has to have infinitely many solutions, or this to have, we have seen this in class, to have non-trivial solution, in 1.2 lectures we have seen, to have non-trivial solution, that a has to be 0. I have shown this actually. Only then in such case the rank of a augmented o is less than n, correct? So this should happen. So similarly, you know, eigenvectors are non-zero, of course. Eigenvectors are non-zero vectors. So which means if this, of course, if x is equal to 0 is a solution, but of course you don't want this to be a solution. Okay, so which means there are other vectors of other values of x which satisfies this equation. So this implies for x bar not equal to 0, this implies the rank should be less than n, which means this determinant is equal to 0. Actually this is how you get the characteristic equation which I have shown you, of course. Okay, so since this system has to have a non-trivial solution, so because of which this coefficient matrix has to have 0 determinant, same thing like this. So this basically gives you the characteristic equation, and once you solve you get the eigenvalues. So first statement, the det of a minus lambda equal to 0 is less than n. That's actually a true statement. Okay, for matrix a power m, m being positive integer, lambda I power m, xi power m will be the eigenpair. Wrong. Okay, the reason is we have seen one very important property. The eigenvectors of a and a power m are same. So if you have eigenpair of a to be lambda I comma xi like this, then for a power m this is lambda I power m comma xi is what you will get as the eigenpair. Okay, so this eigenvector remains same. The reason is, you can see again, I have shown you this in class, ax is equal to lambda x is what you write. Now if you multiply a on both sides, what you can get is a square x, because a operated on a gives you a square x is equal to lambda is a scalar, you can take it out. So if you take lambda out, it's like a operating on x, of course. Okay, and this ax can be again written as lambda x. So ultimately this is lambda square x. So which means you can observe something, this a square x is equal to lambda square x. So similarly if you multiply one more a, it just gives you a cube x is equal to lambda cube x. So this xi do not change actually. Okay, so the eigenvector do not change, values only will change. Okay, so but in the second statement it's given this becomes this actually. Okay, which is wrong because this will definitely stay as it is. Okay, so that will stay as it is. So lambda I power m comma xi. So second statement is wrong. If A transpose is equal to A inverse, then lambda I is mod of lambda I means all eigenvalues are of equal are of unit modulus. See, basically if A transpose is equal to A inverse, if A transpose is equal to A inverse, this means inverse is existing. So if you multiply with A, ultimately this is I, of course. So this implies A is orthogonal. Okay, and we have seen every orthogonal matrix will have eigenvalues of unit modulus actually. Okay, every eigenvalue or every what do you say, every orthogonal matrix, for every orthogonal matrix or for orthogonal matrix, we have seen this property actually. For orthogonal matrix, eigenvalues are of unit modulus. Eigenvalues are of unit modulus. Like you can show this very easily, nothing big deal actually here. So we'll see how you get this. So Ax is equal to lambda x. Okay, so this is the eigen matrix, let's say. So why are we multiplying A with the equation for number of for no reason in option B? In option B, I just want to show you that the eigenvectors of A and A power m will be same. Okay, if you want A power m, then I need to consider higher powers of A, obviously. Okay, so that's why I have shown A square. If you multiply with A cube, similarly you can also see A cube x. If you multiply one more A, this becomes lambda cube x. My intention is to show you as the power of the matrix increases, only the eigenvalue power increases but not the eigenvector power. Okay, but in the option it's given the vector power also increases, power changes, which is false actually. Okay, so for that I have given you this. Okay, fine. Okay, did you get 7 stars? Why this is happening? Because of, okay, then in this case if you multiply A inverse, let's see. Okay, so sorry, if you multiply A transpose A x is equal to lambda times A transpose x. Okay, but you can observe something, the eigenvalues of A and A transpose are same, and the eigenvectors of A and A transpose are basically same only in this I mean A and A power m are same. Yeah, correct. So only for this orthogonal matrix this can be written as lambda square x, of course. Okay, so this is A into A transpose is I x. So if I into x is equal to lambda square times x. So if you take magnitude, lambda square is equal to 1. So mod lambda is equal to 1, of course. Okay, because lambda is plus or minus 1. So basically it can go to complex numbers as well. So this mod lambda is equal to 1 in that case. Okay, the reason is this A transpose x, normally A transpose is equal to A inverse. Okay, and eigenvectors of A inverse and A power m is same. So ultimately this gets the form lambda into x, of course. Okay, so that's why the third statement is also correct. Then the fourth statement, A transpose equal to A, lambda is real for all I, need not be. Okay, sorry, lambda I is real if A transpose equal to A. The elements in A are real numbers for real matrix A. Yeah, then it's 2. Okay, so normally as long as the matrix is symmetric and if all the elements are real numbers, then all eigenvalues are also real numbers, of course. There's no complex number that you have. In fact, we have written one statement, eigenvalues of all eigenvalues of a symmetric matrix are always real. We have written one statement in a class, so because of which only second option is false, A, C, D are correct. Okay, this is the explanation. Fine. Okay, so that's your doubt basically you have sent. Okay, so thank you all. We'll meet tomorrow at around 7 p.m. again. Yeah, and it's okay, no issue. Okay, so we'll meet tomorrow at again 7 p.m. and we'll talk about these applications and beta and gamma function. So finally we'll close. Okay, we'll need one more lecture for that. We'll do that in tomorrow's lecture. Fine then. So thank you all. Yeah, take care. Bye. Good night.